Hi, my name is Emilio.
I am Fernando.
And I'm Hector.
And today we're presenting our project called Analog Weight Measurement Systems. The main goal was to design a simple, low-cost way to measure body weight using our only analog components, no microcontrollers or digital sensors. This is important in contexts where digital systems are too expensive or unavailable, like in low-resource clinics or rural areas.
This system is based on 4 50-kilogram strain gauges, placed under a wooden platform and connected in a full Wheatstone bridge. This bridge configuration helps us detect very small changes in resistance as someone steps on the platform. We used an A01666350 instrumentation amplifier to boost the signal. The gain was set using the 3 30 ohm resistor in parallel. Then, we added a potentiometer to adjust the reference voltage, which helped shift the signal closer to zero when no weight was applied.
After that, the signal went through an A01666350 in voltage follower mode to stabilize it before measurement. We chose these components for 3 reasons: because they are reliable, affordable, and easy to find. The structure was made with wood because it's simple to work with, and even if it's not the most rigid material, it worked perfectly for our project.
This is the A016620 used to amplify the small signal from the strain gauges. About 1.6 mV we had from the output. We set the gain to around 875 using 3 resistors in parallel. Then we added this potentiometer to the reference pin to shift the signal closer to 0 volts. One of the pins were connected to -9 volts, so this helped us reduce the voltage back to 0. So we could use the full 0 to 5 voltage range. Here's the OP07. It acts as a voltage follower to stabilize the signal and avoid distortion when measuring. The circuit is powered by minus and plus 9 volts. Later, we replaced the power supply with 2 9-volt battery to make it portable.
Here we're testing the system live. As weight is applied, the multimeter shows a clear and stable voltage increase. Thanks to the full Wheatstone bridge with 4 strain gauges, we achieved better noise rejection and improved accuracy. Our signal conditioning, including the AD620 and the OP07, helped us reach a precise and fast response, more stable and responsive than many entry-level digital systems. This makes it ideal for real-time monitoring.
We recorded multiple measurements to validate the system's accuracy. So you can see the voltage increases consistently with the applied weight, showing a strong linear relationship, which was our expected result.
This system was designed to be simple, low cost, and easy to build. In places where clinics or schools don't have access to advanced equipment, it offers a way to track weight using basic materials. That makes it useful for nutrition programs, community health centers, or even educational settings.
Because it doesn't need a microcontroller or complex software, it's easier to maintain and repair. Anyone with basic electronic knowledge can work with it. That makes it more inclusive and helps reduce the technology gap between urban and rural healthcare.
The project also shows how engineering can support real community needs. It promotes fair access to health tools, avoid unnecessary digital waste, and teaches how simple designs can still make a big impact in people's lives.
At the end of this project, we all have our reflections and our conclusions. My main role was helping with the amplifier, configuration, and the reference adjustment. It was hard to get the reference voltage just right. Small changes had really big effects. But I learned how important precision and analog design are. This project helped me understand how theory becomes practice, and I feel more confident working with real circuits now. It also showed me the importance of simple functional designs that can be used and worked with in real-life healthcare and circumstances.
Then, I worked mostly on the mechanical structure and integrating the strain gauges into the platform. One challenge was keeping the platform stable and centered, especially with wooden materials. I learned a lot about sensors placement and how small physical factors affect electronic measurements. This project helped me see how engineering choices connect directly to users' experience.
My focus was testing and documenting the results, including signal stability and voltage measurement. I struggled at first with understanding how to read small voltage changes and adjust the system, but I got better through repetition. The project taught me patience and the value of measuring carefully. Now I feel more prepared to future projects and involve data collection and analysis.